Hi everybody, this is our third lesson in our Unit 4, which is all about graphing and optimization. So graphing using the first and second derivatives in order to figure out what the original function looks like. Now what I'm going to do today, if you look at our agenda for today, is that quickly we're going to do a review on the first and second derivatives, what we covered the past two class periods, and then I'm going to actually have you pause and go to do this warm-up on albert.io. Just a few questions that will have you reviewing what we've been doing so that you can kind of refresh yourself, especially after the long break. Then we'll go into today's notes, which is all about curve sketching. Hopefully after you're done with that, you'll have some good time to do your homework and also to work on test corrections for Unit 3, which the first attempt is due by December 6th, which is this Friday. Additionally, the second gateway for the derivatives is open, and I'm having that open until Friday as well. So that means that you should be working on corrections and the derivatives gateway both by Friday at midnight. Okay. Keep in mind as well that Friday we are having a quiz reviewing everything that we will have covered before Friday. So that's the first two lessons, first and second derivative, today's lesson on sketching curves, and the next lesson we will be doing some AP practice questions, all of which you can see here on your calendar if you are confused. So all of this is going to be on your quiz on Friday. All right, so let's go ahead and get started. So we're going to start with doing some review of the first and second derivatives. So I want you to think back to the past two class periods and see if you can remember what do we use the first derivative for, what do we use the second derivative for, and then can you define the critical value and points of inflection? You can go ahead and pause the video here. Try to write that down really quickly. Okay, so hopefully you were able to remember those. So the first derivative, that gives us the slope of the original function. We use it for our test to see where we have an increasing and decreasing function. And then it also is good for extrema. So it tells us the relative min and maximums and then the absolute min and max as well. And then that's in contrast to the second derivative. Second derivative we use for two things. So that's firstly our concavity test. So if the second derivative is greater than 0, then that means we have a concave up part of our graph. If the second derivative is less than 0, it means it's concave down. And then we also use the second derivative for the second derivative test, which is to find relative minimums and maximums. And I only write one down here, but if our second derivative is greater than 0, then that means that at that point we have a minimum. Okay, and then our two other very important vocabulary terms are the critical value and point of inflection. So your critical value, that's where your first derivative is equal to 0 or it's undefined. And this is good for telling us what the possible relative extrema are. And then we also have the points of inflection, and that's where the concavity changes. So that's a review of the first two lessons. Now what I want you to do now is pause the video here and go ahead and do that Albert warm-up. It's just a quick 5 questions that will help you to review what we covered the past two class periods. So pause the video here and give that a try. Okay, but I'm going to move on. So here I have a list of all of the learning targets that we've covered up to this point. It's basically a formal way of saying what we just reviewed. So take a couple minutes to read that. Okay, so the hope is that you are able to do all of these. This is somewhat, you had to do a lot of the first derivative parts on the quiz that you took, and all of these will be on your quiz on Friday, okay? Up to this point, we can do all of this. It's just a formal way of what we had just reviewed. Okay, let's dive into today's lesson. So for today's lesson, here's our learning target for the beginning. That's I can use data about the derivatives of a function to determine the behavior of the function on an interval. So we're not only going to be determining the behavior of the function, but we're also going to be graphing them today, okay? Now with these graphs, I'm not looking for 100% accuracy in all of the values, but each aspect of what I do give you has to be in your graph, okay? And I'm going to walk you through a few of them step by step so that you can see how we can apply or put together basically everything that we've been doing with the first derivative and the second derivative and make it into this curve, this sketch of a graph. Okay, so on this page, you'll see these four tables that give us the function, some values of the function at different points or different intervals, the first derivative and the second derivative. And a couple pages ahead, you have some graph paper in your packet. So if you want to turn to that graph paper, which I think is for you guys, it's just a couple pages ahead, just like this, then you'll be graphing here. And I'm going to be doing all of the work here as well. And I apologize in advance for if this is a little bit messy. It's kind of hard to use the pens on this kind of screen, but with my keyboard, but we'll try to make it work. Okay, so whenever we are doing our curve sketching, what we're going to begin with doing is sketching two number lines, okay? So you can just do it on your graph, or if you want to do it on a different part, feel free to do whatever you want. We're going to do two number lines, and on these two number lines, one of them is, whoops, that's so bad. One of them is going to be for our first derivative, and the other is going to be for our second derivative. Okay, so here's f double prime of x. Alrighty, let's start with the first derivative. Okay, so what of our two values, or of our two important points that we have, critical points and points of inflection, we need to remember which goes with which. So actually, let's go back here. As a reminder, first derivative goes with the critical value, and the second derivative, that goes with the point of inflection. Okay, so just a quick reminder, I should have gone over that at the beginning, but that's okay. All right, so with our first derivative, because the critical points are when the first derivative is equal to 0 or is undefined, that's what the numbers that we're going to put on our number line here. So we look at our first derivative, which is the second row, and we're going to plot any of the points where that's 0 or undefined. So here we have at 0 and at 3. All right, so I'm going to put those two numbers on here, 0 and 3. Perfect. All right, the other thing that we're next going to do is we're just going to give the value of the derivative of x in each of these regions. So when we have x is less than 0, our derivative is negative, right? When x is between 0 and 3, what do we have? Well, this is from 0 all the way up to 3, we have negative. And then when x is greater than 3, we have positive. Okay, now let's think about what that all means, okay? Because we have the negative, 0, positive, but we want to actually give meaning to these. So if the derivative is negative, what does that tell us? That tells us that our function is decreasing. So we're going to draw arrows to show that where we have our decreasing and then where we have an increasing interval. Now, what else can we tell from the first derivative? If you probably remember from the beginning, but we can tell the relative minimums and maximums. So do we have a minimum or a maximum here? We only do if we change sign in the first derivative. So here we go from negative to positive. So if we're decreasing, then increasing, that means that we have a relative min right here. So I'm going to write that here, min. What's happening at 0? Because we go from negative to negative. So what do you think is happening there? If the sign doesn't change, then what's happening is that at one specific point, we're flattening out the slope right there. But we're going to stay decreasing and decreasing. So flatten out for just a second. Think x cubed, right here. So that's what's happening if you're not changing. If it was positive to positive, you would think positive, right like that. So hopefully that gives you a good idea. Okay, so we have all of the information that we need for our first derivative. Let's now go ahead and do our number line for our second derivative. Now on the second derivative, this is our points of inflection, okay? But the numbers that we're going to put here are anywhere in our second derivative where it's equal to 0 or undefined as well. And so here you'll see that as x